Hello students, today we are solving some numericals on unit cell dimensions. In my previous lecture also, I have done a few numericals where I calculated the formula of the compound and also I calculated the edge length when the radius is known and also radius when the edge length is given. Okay. Now the next numericals on the unit cell dimensions. I am calculating here the density of an unit cell. If the other parameters are given, the density defined as D equal to Z into M divided by NA into AQ. This is a formula that we already derived in my previous video. So density is equals to Z into M divided by NA into AQ, where Z defines the type of unit cell and its value is either 1 for simple cubic, is 2 for BCC, and is for 4 for FCC unit cell, and M is mass, atomic mass or the molecular mass, and Na is the Avogadro's number, and AQ is the volume, where A is the edge length. Okay. Now, in the first example, let me read that a silver forms FCC lattice. It forms an FCC lattice, and X-ray studies, X-ray diffraction studies of an crystals shows that the edge length of that unit cell is 408.6 picometers. Then what is the density of that silver? If the atomic mass is equals to 107.9. Now students, first let me write this for let me read the given data. So silver, it forms FCC lattice. This means the value of Z is equals to 4, because for FCC lattice the number of particles in that unit cell is 4. Therefore the Z value is 4, and X-ray studies shows that the edge length is defined as A. Its value is 408.6 picometers. Then another one term given, there is the atomic mass of silver, there is the capital M is equals to 107.9 units, or you can say this is the gram per mole, the atomic mass of silver, and says the density is unknown, so therefore D is equals to question mark. Okay, we know the formula to calculate the density, D equal to Z into M divided by Na into AQ. Okay. Here Z value is 4, M value is 107.9, A value is 408, and Na is the Avogadro's number. Avogadro number, we know Na is equals to 6.022 into 10 raised to 23. That is the Avogadro's constant. Students, the M value is given in gram per mole, whereas the edge length is given in picometers. Okay, so these two, they doesn't have any units. This is the number of particles, and this defines the Avogadro's number. So just check the molecular mass and the edge length. Okay, so units of molecular mass and the edge length both must be in a same unit. Okay, so here I am converting the edge length, that is a 408 picometers, into a CGS system. Okay, so for that I am converting picometers into centimeter. Okay, so this can be written as is 4.086 into 10 raised to minus 8. Okay, so 4.086 into 10 raised to minus 8 centimeter. Now substitute all these values in this formula, you will get the answer. So Z value is 4 into M value 107.9 divided by Avogadro's constant 6.022 into 10 raised to 23 into A value is taken that as 4.086 into 10 raised to minus 8 whole cube. Now d is equals to 4 into 107.9. You calculate, you will get the answer here is 431.6 divided by 6.022 into 10 raised to 23 into. Let me cube these two separate. There is 4.08 whole cube and 10 raised to minus 8 whole cube. So 4.08 whole cube, its value is 67.9 and into 10 raised to minus 8 whole cube is 10 raised to minus 24. 8 3 is 24. Now d is equals to, in numerator keep as it is 431.6 divided by, now 10 raised to 23 and 10 raised to minus 24, only 10 raised to minus 1 remains, and 6.022 into 67.9, and we calculate that, we will get the answer as is 409.01. Now d is equals to, just I have done already the calculation, all this. Okay, just I am putting these values. You can check these by using calculator. 6.022 into 67.9, so it gives 409.01. Therefore d is equals to 431.6 divided by 409.01, so that gives 1.05 into this 10 raised to minus 1 goes to numerator, it is 10 raised to plus 1. So d is equals to 1.05 into 10, 10 raised to 1 means it is 10, so it is 10.5 gram per cubic centimeter. This is the unit of density. As says here, the density of silver is d equal to 10.5 gram per cubic centimeter. Just copy it. Students, next example. Let me read that example. So, an element has a BCC structure, it is a body-centered cubic structure, with an cell edge. The edge length of that unit cell is 288 picometer, and the density of the element is 7.2 gram per cubic centimeter. So, here we have to calculate how many atoms are present in 208 grams of the element. The number of atoms of that element present in 208 grams. And since we know gram molecular mass of any substance contains Avogadro's number of the atoms, Avogadro's number of atoms or particles. So first calculate the molecular mass of the element, then by comparing that with the Avogadro's number, we can easily calculate the total number of particles present in 208 grams. Okay. First, let me read the given. So here is in a BCC structure. BCC means Z value is 2 for BCC. Let us. And next, edge length is given. Edge length is defined as A. A is equals to 288 picometers. That can be written as 2.88 into 10 raised to minus 8 centimeter. As you can see here, 288 picometers means the 1 picometer, let me show you here, 1 picometer is 10 raised to minus 10 centimeter. So just I am replacing that 288 as 2.88 into 10 raised to minus 8 centimeter. Okay. Now, the density of the element is given, d is equals to 7.2 gram per cubic centimeter. Then calculate the molecular mass or gram molecular mass of that element. Molecular mass of that element m is equals to question mark. And also another one data we know, that is the Avogadro's constant, that is 6.022 into 10 raised to 23. Last time, the formula is d equal to z into m divided by Na into A cube. Okay. So m is the unknown, so therefore I can write this formula as m is equals to this cross multiply is d into na into A cube divided by the z. Now m is equals to, now I will substitute all these values in this formula. This is a modified formula to calculate the molecular mass. So density is 7.2 grams per cubic centimeter. Just I am writing the values here. So Na is Avogadro's constant. It is 6.022 into 10 raised to 23. A cube, where A is the edge length. So edge length is 2.88 into 10 raised to minus 8 whole cube. Divided by z value. Z value is 2 because it is an ABCC lattice. So therefore z is equals to 2. Now I will simplify numerator and denominator. Before simplification, first find the cube of this term. Okay. So cube of 2.88. Now m is equals to is 7.2 into 6.022 into 10 raised to 23 into the cube of 2.88 whole cube is equals to 23.88 into 2.88 whole cube is 23.88, just check. So 10 raised to minus 8 whole cube. So 10 raised to minus 8 whole cube is 10 raised to minus 24. 8 3 is a 24. So divided by 2. Now m is equals to, so here 10 raised to plus 23 this term and 10 raised to minus 24. I write that as 10 raised to minus 1. Now 7.2 into 6.022 into 23.88 divided by 2. Multiply first all these terms, then divide that by 22. You will get the answer here as 517.8 into 10 raised to minus 1. Now m is equals to 10 raised to minus 1 multiply with 10 raised to minus 1 means dividing by 10. So its value is 51.78 gram per mole. And since here this is the molecular mass of the substance. Okay. So molecular mass of that element. By knowing molecular mass, we can easily calculate the total number of particles present in this much grams. So let me write one small conversions, that is 51.78 gram per cubic centimeter. The mass of that element will equivalent to 6.022 into 10 raised to 23 number of atoms. Okay. This is the mass of 6.022 into 10 raised to 23 number. Okay, that is called a gram molecular mass. Now, in question, they told to find how many atoms are present in 208 grams. In 51.78 grams, it contains 6.02 into 10 raised to 23. Then 208 gram of the substance contains how many atoms? So there is a simple mathematical conversions. So this is a gram molecular mass, contains Avogadro's number of particles. Then 208 grams contains how many atoms? Okay. So therefore, let me simplify this. This is equals to 208 into 6.022 into 10 raised to 23 divided by 51.78. Okay. So simplify that, we will get the answer here as, so is 24.19 into 10 raised to 23 number of atoms. So here the total number of atoms present is equals to 23. So 208 into, I'm putting the dot here, so it is 208 into 6.022 divided that by 51.78, you will get answer as 24.19. Okay, that is the total number of atoms. Okay students, next example is the edge length of NaCl in its cell is 564 picometers. What is the density of NaCl in gram per cubic centimeter? So the answer should be expressed in gram per cubic centimeter. As here, only one data is given. The given data edge length of NaCl is 564 picometers. Then they ask density of NaCl in gram per cubic centimeter. As we know the formula is D is equals to Z into M divided by Na into Aq. As here, Z stands for the type of unit cell. Z is the number of particles present in that unit cell. Okay. So its value depends on the type of unit cell. So what type of unit cell is found by NaCl is not given, but we know that sodium chloride, it is sodium chloride crystal, its unit cell is of the type FCC. Okay. So therefore Z value is 4. And NaCl has FCC in its cell. Therefore Z value is 4. And since M value, there is a molecular mass of NaCl. We know M is equals molecular mass of NaCl is, add the atomic masses of these two elements. So chloride, it is 35.5, sodium is 23. So molecular mass is 58.5 gram per cubic centimeter. And next, Avogadro's constant. We know Avogadro's constant value is Na is equals to is 6.022 into 10 raised to 23, and Aq, A value is given 564. Convert that picometer into centimeter, so it becomes 5.64 into 10 raised to minus 8 centimeter. Now substitute all these values in this formula and calculate the density. So density is equals to, first Z value 4, mass 58.5 divided by Avogadro's number 6.022 into 10 raised to 23, and A value, H length is 5.64. We converted the H length from picometer into centimeter. So we can, and also we replace the decimal from 100 to an single. So here 5.64 into 10 raised to minus 8 whole cube. Now D is equals to, so if I multiply 4 into 58.5, you get 234 in numerator, 234 divided by, so let me write another one step, 6.022 into 10 raised to 23 into 5.64 whole cube and 10 raised to minus 8 whole cube. 5.64 whole cube, this value is 179.4 into 10 raised to minus 8 whole cube is 10 raised to minus 24. 8 is a 24. Okay. So students, check all these values by using calculator. 5.64 into 5.64 into 5.64. So it gives 179.4. Now density D is equals to, in numerator 234 divided by, here 10 raised to 23 and 10 raised to minus 24 gives 10 raised to minus 1. So 10 raised to minus 1 goes to numerator, it is 10 raised to plus 1. Okay. And 6.022 into 10 raised 6.022 into 179.4 multiply, we'll get 1000 and 80. Then D is equals to, so 234 divided by 1080, it will give me the answer as 0.216 into 10 raised to 1. So therefore D is equals to 2.16 gram per cubic centimeter. Okay. So this is the density of Na sodium chloride. Next example, a metal with atomic mass 50 units or gram per mole 50 has a body center cubic structure. If the density of the metal is 5.96 gram per cubic centimeter, then what is the volume of that unit cell? Now since, let me read the given in this example. The given is atomic mass is defined as capital M 50 gram per mole, and next it has a body centered cubic structure. That means Z value is 2 for BCC, body centered cubic structures. Z value is 2. Then the density of the metal is given. Density is defined as D is equals to 5.96 gram per cubic centimeter. Then it told to find the volume of the unit cell. So volume of unit cell is AQ, where A is the edge length. For cubic system, AQ is the volume of unit cell. Right. The volume of unit cell is equals to AQ, that is equals to question mark. Now, we write the formula which relates the density and the volume of unit cell. The formula we know, that is Z is equals to D equal to Z into M divided by Na into AQ. Okay. So here Z is known, Z is given, it is 5.96. D is given 5.96, Z value is 2, M value is 50, Na is the Avogadro's constant, and A cube is the unknown. Let me rearrange this formula for A cube. A cube is equals to, let's cross multiply density and A cube. So A cube equal to Z into M divided by Na into D. Let's have cross multiplied these two. Now A cube equal to this. Now substitute the values in that formula. Z value 2, M value is 50 divided by Avogadro's constant 6.022 into 10 raised to 23 into density 5.96, that is equals to 2 into 50, 100 divided by 6.022 into 5.96, so that gives 35.89 into, so I am taking this 10 raised to 23 in numerator, that means is equals to 10 raised to minus 23. Now A cube is equals to, divide 100 by 35.89, so you will get answer 2.786 into 10 raised to minus 23. So 23 centimeter cube is the volume of the unit cell. Let's write it. Okay, students, next example, another one example is also very important. Look at the board. An element X with atomic mass 60 gram per mole. An element, as in any element, X, its atomic mass is 60 gram per mole, has a density, and its density is 6.23 gram per cubic centimeter. If the edge length of the unit cell is 400 picometers, then identify the type of the unit cell. Okay, so what type of the unit cell is found by these unit cell dimensions. Okay, so here the certain parameters, unit cell parameters given. So one is the unit cell element whose atomic mass is 60 and density is 6.23. Let me write the given data. Given atomic mass, we define atomic mass as m, or molecular mass also m. So atomic mass is m and its value is 60 gram per mole. Then density is defined as d is equals to 6.23 gram per cubic centimeter. Next, edge length of the unit cell. Edge length we define that as 400 picometers. So 400 picometers, express that into centimeter as 4.00 into 10 raised to minus 8 centimeter. Then identify the type of unit cell. So type of the unit cell means whether the unit cell is in a simple cubic or it's in a body centered cubic or face centered cubic. We know the type of unit cell is defined by a symbol Z. Z defines the type of unit cell. If Z value we got 1, then the unit cell is in a simple cubic. If we got Z value 2, then it is in a BCC. If we got answer Z is equals to 4, then it is in a FCC unit cell. So therefore calculate the Z value. Now write the formula D equal to Z into M divided by NA into AQ. So here Z is unknown. Let me rearrange these terms. So D into NA into A is cross multiply. It is D into NA into AQ divided by, so here M comes to denominator, so Z remains. So therefore the Z is equals to D into NA into AQ divided by capital M. Now Z is equals to, D value is 6.23. Substitute all the values in that formula. Okay, Z is equals to D 6.23 into NA is the Avogadro's constant and its value is 6.022 into 10 raised to 23 into AQ, where A is the edge length. Edge length is defined here, it is 400 picometers and we converted that picometer into centimeter. So 4.00 into 10 raised to minus 8 centimeter. Now, so instead of 4.00, simply I am writing 4 into 10 raised to minus 8 whole cube divided by capital M. Capital M is the atomic mass of element X. So atomic mass is given 60. That is equals to Z is equals to. Now first, before multiplication, let me clear this bracket. Okay. Find the 4 cube value. 6.23 into 6.022 into 10 raised to 23 into 4 whole cube. 4 whole cube we know, 4 into 4 into 4 is 64. 4 4 is 16, 16 4 is 64 into 10 raised to minus 8 whole cube is 8 3 is 24. So minus 24 in denominator as it is, giving 60. Now multiply these terms, 6.23 into 6.022 into 64, then divide that final answer by 60. Okay. So after dividing, you will get the answer here. Z is equals to, I'm going to get the answer as 40.0 into 6.23, 6.022 into 64 divided by 60. Okay, that is equals to, you get 40.0, and 10 raised to 23 into 10 raised to minus 24 is 10 raised to minus 1. Then z is equals to 40 into 10 raised to minus 1. 10 raised to minus 1 means divide that by 10, so that is equals to 4. So here z value is equals to 4. Z value 4 means, so this element x, it has a FCC unit cell. You can write here. So x has a FCC unit cell. So this is the first part. Okay. So we identified the type of unit cell. The unit cell is an FCC unit cell. FCC means face centered cubic unit cell. And next, and second part is it will calculate the radius of an atom. Okay. So let me, this is in the first part. So 1, Roman 1, and second part. In second part, radius of atom is equals to question mark. Okay. So when we know the type of unit cell, then we can easily write the relationship between the edge length and the radius of sphere. Okay. Without knowing the type of unit cells, not possible to write the relationship between the R and A. Okay. So R is equals to question mark. So here for FCC unit cell, we know edge length A is equals to 2R into root 2 or 2 root 2 into R. Okay. So now substitute rearrange that for R is equals to A divided by 2 root 2. Now substitute the value of A, edge length value is 400 picometers or 4.00 into 10 raised to minus 8 centimeter. And then 4.00, let me take 4.00 into 10 raised to minus 8 divided by 2 root 2. So it is 2 into root 2 value is 1.414. Okay. Then R is equal to, so simplify that, 4 divided by that, finally you will get the answer. It is 141.4 into 10 raised to minus 8 centimeter. This is the radius of sphere. Okay, so here 4, we expressed this in centimeters means, so it is not 141, it is 1.414 into 10 raised to minus 8 centimeter, or we can express this in picometers means it is 141.4 picometers. Okay. So that was the answer. Next, another one example, students, on that formula density. Here, let me read the problem. Calculate the density of silver which crystallizes in FCC form. The unit cell of the silver is FCC form, and the distance between the nearest metal atom is 287 picometer. The distance between the nearest neighboring atom is given. Students, here we know the arrangement of particles in FCC unit cell. In FCC unit cell, the diagonally opposite corner particles and a phase center particles, they are in touch with each other. That means the phase center particle and diagonally opposite corner particles are the neighbors, and this is the arrangement in FCC unit cell. So the distance between the nearest metal atoms, that means the distance between these two neighboring atoms is given. This distance is given. So the distance is equals to 287 picometers. We know the distance between the nearest neighboring atoms is defined as 2r, because the radius of first sphere is r and the radius of second sphere is also defined as r. Therefore 2r is equals to, 2r value is 287 picometers. 2 are equal to 287 picometers is the given, and also other parameters which helps in solving this example is FCC form. That means Z value is given. Z value is 4 for FCC, and atomic mass is defined as capital M. So capital M value is 107.87 gram per mole. Then let's find the density D equal to question mark. Okay, so here D equal to question mark. And since we know the formula to calculate the density is Z into M divided by N into AQ. Okay. So Z value is 4, M value is 107.87, and capital M value and Z value, and in denominator Na is the Avogadro's constant. Its value is 6.022 into 10 raised to 23. There is an Avogadro's number, and another one parameter is AQ. AQ is the volume of unit cell. Okay. So to calculate AQ, we need H length. H length is not given, but 2R value is given. Okay. And also the type of unit cells. By knowing these relationship between the type of unit cell and the radius, we can write the H length as A is equals to 2 root 2 into R, or it is 2R into root 2. Okay. 2R value is given, it is 287. Let me substitute that 2R value 287 into root 2 value, we know it is 1.414 root 2 value. Okay. Therefore, A is equals to 287 into 1.414 multiply, you will get the answer is 405.8 picometers, 89 picometers. This is the A value. Let me calculate A cube here only. A cube equal to cube of this. Okay. Before finding the cube of this, express this picometer into centimeter, because the molecular mass is already expressed in grams per mole. So convert this picometer into centimeter. This can be done as 4.05 here is 4.058 into 10 raised to minus 8 centimeter. Now A cube equal to 4.058 into 10 raised to minus 8 whole cube. Okay. So you can easily find the cube of this term, 4.058 whole cube. Okay. If you take the cube of this, that is 405.89, in simple calculator you may not find all the numbers. Okay, that's why we convert that 405 into 4.05. Okay, you can easily get all the numbers after cubing. It is 4.058. Therefore, A cube is equals to, so A cube equal to 66.92. Cube of this term into 10 raised to minus 8 whole cube is 10 raised to minus 24. Okay, this is the A cube value. Now, let me write the density formula. D is equals to Z into M divided by Na into A cube. Z value is 4, M value is 107.87, and the Z value is 4. M value given, atomic mass 107.87 divided by Na is the Avogadro's constant, its value is 6.022 into 10 raised to 23 into A cube. Thus we calculated the A cube 66.92 into 10 raised to minus 24, and density D equal to. So first let me remove this 10 raised to 23 and 10 raised to 24. 10 raised to 23 into 10 raised to 24 is 10 raised to minus 1. So 10 raised to minus 1, if I take that numerator, means it becomes 10 raised to plus 1. Now in numerator multiply 4 into 107.87, we will get answer 431 in numerator divided by, in denominator multiply the Avogadro's number 6.022 into 66.92, we will get answer as 402. Then density equal to, so 431 divided by 402, so that is equals to 1.07 into 10 raised to 1. So 10 raised to 1 means just multiply that by 10. So therefore the density is equals to 10.7 gram per cubic centimeter. So D is equals to 10.7 into 10.7 gram per cubic centimeter is the density. And there few examples are given in NCERT textbooks. Practice those problems also, so as an assignment. Now copy this.